Hi everyone, welcome to our meetup. My name is Maria and I'm an international business consultant at Quijust. Today with me is João Nunes, our quality assurance automation engineer, and we will be sharing some thoughts and some inputs on a very interesting topic, and I'm sure a source of many headaches for many people that have been participating in our event today. That is inbuilt quality assurance procedures in software development. Before we start our session, I would like to ask everyone to use our chat during the conversation to ask questions. We will have a Q&A session at the end where we'll be probably bombarding you all with all of our doubts and insights. And you can also use it to present yourself to our network. So here's our agenda for today. Before we start, I would like to explain to you a little bit more of what is Quijust. So for those who don't know, Quijust is an international IT company based in Lisbon, Portugal, with more than 30 years of experience in digital transformation worldwide. We have been pioneers using artificial intelligence to automate software since 1988, and we created our own tool that's been called Genio. And as a tech company, and I'm sure we have a lot of developers with us today, we've been struggling with the lack of ICT profiles in the market, and this was one of the main reasons that we started to apply automation to our processes of development. So fighting against this digital gap became also part of our mission as back in 1988. And Genio is what makes us so special to our clients and to our partners and to our developers as well. It's been enabling us to transform and innovate in 12 different fields and in more than 200 entities worldwide with a team of less than 100 developers. It's been an added value to digital strategies, from the update of obsolete platforms to the implementation of unique solutions, and always with the mindset that the solution should always adapt to the needs and to the necessities of the market and of the clients, but also to enhance transformation by itself. And for it to do that, it should be constantly improving. And this capacity of quick adaptation and response to new challenges that has been recognized as our added value to our partners and our network out there, from multilateral agencies such as the United Nations that we've been working since 2010 to Microsoft and so on. So Genio is an innovative pattern-based framework that is enabling us to transform the ideas of our clients into efficient, future-proof, open source software solutions. It's been enabling also us to practically implement the newest technologies out and the newest methodologies out there. And this builds the bridge on the topic that we have today. It is on how to improve quality assurance practices in software development. So starting our conversation here with João. João, first of all, thank you for participating in our meetup today. To start our conversation, I would like to ask you, what do you think at the moment are the main challenges of our industry, of the tech industry, at this point when it comes to quality procedures on software development?
Well, first and foremost, I would like to thank you for the invitation and for the opportunity to talk about this topic. It's a very interesting and actual topic. And going towards your question, so what are the main concerns of the industry right now regarding quality assurance? I think software, broadly speaking, has become more and more complex, and this complexity often translates into various dependencies and having to build software that has to work properly and execute its function properly in a variety of different environments and different configurations and different settings. So I think one of the main challenges right now is to be able to have a complete test of a system based on that is able to predict and to evaluate, to verify, to test these kinds of variables, which some of them are not so easy to control. So when we talk about quality assurance, we're talking about every moving part of the process that actually puts together a software has to conform and has to have some kind of verification and validation to help mitigate this kind of variety and an ecosystem of different environments and configurations where software has to run, and we have to try to guarantee that the software will run correctly in all these configurations.
Okay, thank you, João. But do you think that apart from the many challenges that we have, do you think it's also a challenge of misconception? Meaning that, do you think that people often don't create a difference between what is quality control and what is quality assurance, for example?
Yes, I think even in, well, software industry is a little bit different than other industries. There are some different paradigms, but at the same time, I think it's very common to have a misconception about quality control in software. And what we want as an industry and to be able to actually provide quality software is not quality control, because the main misconception is that testing phase and quality control is achieved or is done on the final stages of the development process, where you try to test the software almost in the finished state and not during the process. And what this means is, so the key difference between quality control and quality assurance is when the tests and when the validations and verifications are done, meaning that the quality control is usually performed at the end of the development cycle. And this poses a lot of problems and a lot of difficulties to the process, in terms that, for instance, if you identify a mistake when you're doing quality control, so you have already your final product and you're doing some testing upon the final product, and you discover that you actually have a fault, a defect on the product, you oftentimes don't have any notion where the error or the defect originated. And this is the key difference between quality assurance and quality control, is that we want to find and identify the mistakes and the errors and the defects as soon as we can, so that we can also identify their causes. And quality control usually is not good at doing this. So quality control is good at evaluating if the product conforms to the requirements or not, but it basically acts as a triage, but it doesn't help to improve the process, and doesn't help to identify the error, the origin of the error. And this is kind of a fault, because sometimes it takes a lot more effort to understand where the mistake is, where the error is originating, rather than understanding that the product has a defect. So we want, this is the key misconception I think software industry has towards quality assurance, is that it suffices it's enough to just perform final testing and quality control tests. And our philosophy here in Quidgest is a little bit different, where we try to embed and incorporate the testing phases throughout the processes, throughout the development process of the software, so we can improve the process itself and identify quickly and cheaply, so in the timely fashion, where the errors are being, what is causing the errors, and how can we fix it, and how can we prevent these kinds of errors never reaching the final product. And we can almost eliminate a couple of quality control tests if you actually do this.
Thank you, João. Quickly and in a very cheap way, or quickly and cheaply, right?
Exactly.
These are two points very, very important to everyone out there that's been listening us, and that's been for sure struggling with this misconceptions and these problems regarding finding errors in their systems at the end when the production is almost over. So do you think that, and if we've been seeing a lot of new methodologies coming out in the market and new ways of doing things in so many parts of the development phase of a solution, do you think that there are principles or methodologies out there that you find it to be the most relevant ones at the moment to apply to software development when it comes to quality?
There's no lack of different methodologies and ideologies and philosophies about how to actually achieve this quality in software. And we have lean, we have agile, we have a bunch of concepts that almost, some of them overlap a little bit, but I think the best ones are the classical ones, and they come from, I think, the core principles we'll try to incorporate here in Quidgest as well, and in the sense of quality assurance in software in general. I think the key concepts that are important to study and to understand are the ones that come from the Toyota production system. So Toyota is a brand that makes cars. It's world known for their quality and their products, their cars. And they, after the Second World War, they had an opportunity to, they had to reinvent themselves, and they had to try to build a better way they had to evolve their industry. And so they took the opportunity in some sense to restructure a lot of their industrial processes and the way the philosophy behind the industry. And we're talking about Toyota, which is connected to cars, but at the same way, these kinds of lessons and principles are so generic in the sense that they apply to, nowadays, they apply to almost every industry. And these core concepts that I want to focus on are mostly Kaizen. I'm gonna try to explain just briefly what's the meaning of these concepts, but we can dive into more details afterwards. So Kaizen means improvement. Kaizen is one of the core ideologies behind the Toyota production systems, and it means that every every bit or every small process, sub-process, every component, every worker, every technician, every part of the process has to be continuously improved on. So there are not dogmas, there are not fixed parts, there are not fixed processes, and so we always try to improve and look at ways how to improve these processes and these moving components that build up the process. So Kaizen is one of the key principles. Another one that is also widely adopted by software industry and a lot of other industries is Kanban. Kanban means visual signaling, and this kind in the factory when building cars. Visual signaling would help to workers to know how much work is going on, which stations, which processes are having more work than others, which processes are able to kind of output the expected numbers and the parts that are needed for the process to keep on going. So Kanban means there are Kanban boards on software. Every main software methodology usually incorporates a Kanban into their workflow, because it's just a way of dealing with knowing what everyone is doing at any time, and managing the workload of each person or each team, and instead of having a fixed how do I say, fixed timing to perform certain actions and expecting people to always perform things in a certain timing. And in software development, this is kind of hard to guarantee. So because we don't want to have a lot of backlog, we don't want to have an infinite to-do list and an infinite work in progress, and Kanban helps to deal with this and helps to manage workflow and work loads for each person. And so Kanban is also one of the core principles from the Toyota production system that software industry uses, and I think it's very useful. And finally, and probably the most important one, and the one that we kind of want to focus more, is Pokayok. And Pokayok means mistake prevention, or mistake elimination, mistake proofing, mistake prevention. And the idea behind this is, instead of as I was talking before, instead of waiting for the final product to perform a verification, a validation, if everything is built, is well built, and if all the parts are working and if they work together, and just perform this at the end, the Pokayok actually tries to catch the error as soon as possible, so that we don't have to rely on mass inspection. And Deming was also a very influential person during the Toyota production system conception, and he was very influential in the reconstruction and the industry reconstruction in Japan. Deming, the third principle from Deming is basically to cease dependency on mass inspection, and to kind of, instead of having mass inspection at the end, which is usually associated with quality control, to push these kind of validations closer to the processes and the build processes, so that we can find the errors and improve the processes quickly and sooner than rather later. And so Poka-yoke is one of the key concepts that I think it helps a lot in quality, in assuring quality in software, because it's basically saying avoid, try to put, like, it's a bunch of different mechanisms that helps you identify when you're doing something wrong. And if you have these kind of mechanisms in place, you avoid propagating the error towards the final product, and and it actually helps you to diagnose the origin of the error, because if you have these kind of mechanisms throughout the process, like we can identify very soon and quickly and also cheaply where the error is happening. We can stop the process. We can fix the origin of the problem, and then we can assure that the final product won't have these problems. So Kaizen, Kanban, and Poka-yoke, I think, is the core principles that we like to, that I think it's the most important for quality assurance in software.
Okay, many principles that we could use in practical terms. A question that's probably a bit problematic in a way of answering it is, what happens to the testing teams? So we have all these principles being applied during the development phase. What happens to the idea of the testing teams, of having a testing team that's going to act synergistically in a phase during the development to check bugs? So what happens to them, right?
Mm-hmm. So that's actually a good question, and we have different important personalities in the software industry that have different opinions and they have different views on this. But we want here at QuickJust, we want to strive for, we want to push our opinion, and our opinion is that testers are actually redundant and not needed. And whereas some people can argue that, oh, but having a tester is cheaper than having a developer or a programmer doing the tests, and so that's one of the main how do I say, the main the main advantages of having testers is that they are cheaper and often, so you kind of, then you can spare the developers and you can spare the programmers, and having a dedicated testers like avoids and frees up some time for the developers. And at the same time, because developers are more expensive by the hour than testers, somebody could say, like, then it's more efficient to have testers, to not charge, or to not put it as a responsibility for the developer to actually do the testing. But we kind of want to say that this is wrong, and we don't agree with this kind of view. We don't agree with having a separated team of testers and having testers in general, because it means that there's a clear separation between the development process and the testing process, and we don't want that. We think that this is actually one of the things that makes quality assurance more challenging in software industry, is that it's often very difficult to communicate in a manner that is useful to the developer. What is happening? What's the error? How the error is what have you done, and how do you think you could fix it? And so having a separated team of testers and developers, just between just the communication that has to happen to be able for the developers to understand what the testers are saying, and to have an idea and an intuition what's wrong and how you have to fix it. Having separated teams doesn't help with this. And so what we see nowadays in the industry, that most companies actually still have dedicated testers. What we actually see is that they spend a lot of time just trying to communicate what the findings, the tester findings are, and the developers just translating the results of the tests to actually be able to fix the problems. So what we advocate, and what I personally and here at QuidJest we advocate this, is the developers, and while you're working and developing a feature, a product, a software, a component, it doesn't matter. While you're developing, you're also responsible for testing it and making sure what you're doing is functional and it's working. So it's a bit of more responsibility on the software engineers and the developers to actually do this, but at the same time it provides a lot of a safety net that catches errors as soon as possible. And because if you're a developer doing a certain feature, it also helps a lot. You'll probably have a better notion than a tester what to test for and how to test it, rather than the tester not having a clue how the implementation works, or what's the algorithms that are working behind the scenes. And this makes the tester less effective than a developer when doing the tests. And so I think we should strive for, and I think it should be a change in the industry, and to kind of to be able to achieve quality to be able to achieve quality in software. I think this kind of mentality has to change, and developers have to be responsible for also producing and doing the actual testing on the components they are building. And this puts it in another scale, the speed and the accuracy at which you can solve the actual problems and the debug things and trim out the defects and trim out the errors.
Wow, Jean, that's really a changing of mindset, basically, for the entire industry. And I'm sure there are many people asking the same questions I'm going to ask to you now. So, okay, this is awesome. This is really a game change. How do we put this into practice? How do we apply this internally? So how can this be applied in practice, João?
Okay, so, well, as I said before, there are a lot of ideologies, and I'm personally, I think sometimes it's better to have something that works rather than something very pretty in the paper and in the ideas that actually doesn't work and doesn't work for you. So being pragmatic and being able to apply these concepts, it's not easy, and it doesn't suffice to just say, oh, we are a lean IT company, or we use the agile methodology. This doesn't mean anything until you kind of see the work and see this in practice, and developers and the product and the customers feel the improvements from it. So I think to be able to achieve this and to put this in practice, and I'm gonna say a couple of examples, but So for instance, documentation is one of the most important aspects on software development, and sometimes is it falls to a second plane. But this is a kind of example of Kaizen, of continuous improvement, and a process that should involve everyone in the company, from the CTO to the technician, or even the customer, can help build better documentation. And documentation can help avoid problems, can help avoid errors, and avoid time consuming and money consuming mistakes. So this is kind of an example of Kaizen. Um, More towards the Pokayoke mechanisms that we see in uh, many places in our daily lives. Like for instance, USB port. When you try to put the USB stick on the USB port, and if it's not on the right orientation, it doesn't plug in. So it doesn't let you plug in wrongly. And these kinds of mechanisms we kind of put put them on our software. So the idea and how to the idea is that when you're building features and you're programming a new feature, you're also building a set of tools that help you validate what you're building. And because here at QuickJest we use an approach based on using models, and we use models because they let us reuse codes, and they let us create an abstraction that provides us, that enables us to be quicker to market and quicker to develop new projects, new software. And this kind of approach with models also is very good for quality assurance, because it's a singular point where you can accumulate knowledge and expertise and verification from all the software that we've built, and it stays on the model that was used to generate this kind of software. So I think I'm giving like a long answer, and I think there are small examples, like for instance, being able to validate the entity model, the relational model on the database. And for instance, when we're building the relational model, we use a tool that validates if the relationships are that are right, if the data types are compatible, if the foreign key is present, so we build a lot of tools that actually prevent us from doing certain mistakes, and helps us to guarantee that the specification and the configuration and all the setup and all the coding is built right. And these kinds of tools can all be thought of as Pokayoke mechanisms that help us find the errors as soon as possible, fix them, and keep improving the process itself by adding a new verifications, for instance. So if we have an error that is happening in a product and a software that was built from us, for like we take this specific information about one error, and because we apply it, the fix and the verification process to a model, it means that we propagate this kind of knowledge to all the products that we produce. And everywhere that model is being used on, it doesn't matter if it was improved, where the improvement came from, it will be propagated to all products. And so these are some of the mechanisms and the ways you can achieve quality assurance, and you can put in practice this kind of principles and methodologies. but I would also argue that it has some room for adjusting to each company's profile, each developer's. So the idea here is these are a little generic concepts. So it comes with some flexibility, and I think this flexibility is also good to be able to implement these kind of principles in a useful and in a good way.
Okay, so then closing in here our session of questions.
Mm-hmm.
So here at QuickJS, we've been using and we've been in-building quality procedures and all these principles in Genio, and this has been, and we're being applying automation where we've been thinking quality since its concept at QuickJS. Do you think that the answer or the easiest way to implement this internally should go from or through the use of an automated platform such as our model-driven development tool, our Genio?
Yes, definitely. I think automation is a core concept around software. So we build software to automate things. So information technology is all about automation, all about being able to do things quickly and to not have to do repetitive tasks. And so to be able to actually guarantee some kind of quality, to be able to achieve this regularly and consistently, you have to build this upon some kind of automation. It's not practical to think that each time we want to make sure everything is plugged in right and is working fine. It's completely wrong, and I don't know, almost impossible to think that we can have manual to do. We have to do this verification manually. So a lot of these concepts are actually built upon automation, being automation a key principle in software in general. And so this kind of mistake prevention and error prevention, mistake proofing, this kind of guarantees and tests that we do to achieve quality on software, it has to come from automation. And so Genio, in this sense, and working with models and reusing code and having a good structure to build software is actually one of the most important things. And so a lot of quality also comes from design, not just by testing the product. So if it's a poorly designed process, if it's a poorly designed system, the requirements are not very well defined, it's going to be very hard to actually look at the software, the final product, and look at it and say that it's perfect and it works fine. It probably won't work. So in order to actually guarantee quality, we have to build these kinds of automations, these kinds of mechanisms that help us identify mistakes and identify errors as soon as possible. And they all contribute, it's all part of quality assurance, and they all contribute to a better software in the end.
Okay, thank you so much, João. It was great, all the inputs and insights that you shared here with us today. And for those out there who are interested in finding more about our Genio and the way that you can use it in your own projects to also enhance this quality inbuilt approach that we've been applying at QuickJS, I would like to challenge you to participate in our Genio Academy. We created the Genio Academy back in 2018 when we became part of the Digital Skills and Job Coalition of the European Commission. We wanted to tackle not only the gap of digital skills that we have in the European market so far, but also to enhance the best methodologies and tendencies that have been applied to software development out there. And one of the major tendencies that we've been seeing so far is actually coding becoming increasingly AI assisted. And as a result of this, we have major increases in productivity and in quality, as João stand out during this session. Our actions and our trainings range from certified training sessions to boost your digital career by becoming a junior developer, or being part of our international trainers at Quitjust to support your research projects and innovative projects that you have. We've been doing this also in partnership with some of the main universities in Europe, and also to accelerate your digital transformation strategy if you are an entity and if you are a startup, for example, that wants to leverage a business idea, but either you don't have the tools to do it or you don't have the resources to do it. So this is a great opportunity for you to be part of this new trend that we've been applying to the market, and also understand more in detail how can these inbuilt resources that we've been applying to GNU could improve your own way of doing and developing software. And to find out more about what kind of GNU fits you best, you should check out the diagnostic form that we provided. We just created specifically for this session for you. It's also a great way to give us feedback about the session and let us know what ways we could improve it to the next ones. And now we are officially opening our Q&A session. So guys, this is the best opportunity for you to ask questions to João. And I'm opening it directly. Let's see if we have any question in our Q&A. Okay, so Sara has been sharing the link to our form. So I know that people are taking their time to understand what are the best questions to ask João. I have one question that I think it's important to discuss. So if we want to eliminate all these tasks associated to the quality control, how do we ensure the quality of the software itself? So I know that we've been discussing that this should go through automatizing and thinking about quality from the beginning, but how in practice how do we manage this internally? And how do we manage this with the client when we say that we're not actually testing things, we're having this inbuilt? How do we manage this with the client, for example?
So arguing that we shouldn't be doing quality control tests doesn't mean that we don't test the final products, okay? So we are arguing that we want to distribute the testing throughout the process and not just in the final stage. So by saying that we want to get rid of the quality control phase and the quality control tests, it doesn't mean that the final product and the final software is not going to be tested. So, and a little bit picking up the last question that you asked me about the automation and what's the purpose and the role of GNU in kind of helping to guarantee this quality in software. It really comes from automation because it has being able to automate the process where you build the software makes you able to kind of make certain assertions and to guarantee that in each step of the way, each step of the process, everything is working as it should. And there's no computers are deterministic and so deterministic machines, and so if you're testing each component separately, and then you can design some tests that, because we're using these kinds of models and we kind of have generic abstractions for these patterns and these templates models, we can also build integration tests that can be parameterized by the configuration of the software that we're building, to make sure that at the final stage, like we have various tests throughout the process, and at the final stage where we can already assume that each component has been tested individually, and at the final stage, because of this kind of template and model driven developments allowed by and enabled by Genio, at the end we can also generate very complex and integration tests that actually make sure that each component works well together. So when we say that we don't want quality control testing, it doesn't mean that we're not actually testing the final product. We're still testing it, but we are not testing it manually. We're not testing it with a separate team. We're not doing a different scheme of things, a separate scheme of things to be able to test the software. It's completely built in the software development process. And when you're pushing, when you're compiling a new version of the software, it also compiles and generates a couple of tests that will be run upon the final software. So what we want is that you're not able to run from testing. It should not be possible to generate and to produce a software that hasn't been tested. It doesn't need more testing because it has been tested extensively throughout the process, and we can make a good assumption and guarantee that the quality is there, because we've riddled and we've put a lot of tests throughout the testing each component individually, and so it makes us, and the experience so far, I think it's a bit of an anecdotal evidence, but from our experience and our customers, our clients, it has been working very well. And often clients even say that our software usually seems more with more attention to details than others, because these kinds of small tests and small verifications that are all in place to make sure that these kinds of mistakes and attention faults, something that some programmer forgot to put in, these are caught up during the process and never reach the final customer and the final product.
Okay, thank you, João. We have a couple of interesting questions in our Q&A. The first one is from Rita Sant. Rita asks you, João, what's the biggest challenge to quality assurance now?
Okay, I think the biggest challenge is the cost of implementation and the cost of change. And there are a lot of interesting papers and interesting people talking about this. When you're trying to change the culture and change the processes, how a company works and how the company produces its products, it's even the human being is really resilient to change. And so I think one of the biggest challenges to quality assurance right now is convincing the companies and the developers that it's worthwhile to implement these kinds of testings and this kind of mentality and principles and methodologies, because it's usually, in software development, we have a saying that we like a lot to say, that is, you should not reinvent the wheel. So if you it takes a lot of time to develop a wheel, but after it's developed, you should use it, and you should not be worried about developing a new wheel, because it will be 99.9% similar to the one that was already built. So the idea here is that it's hard to evaluate the value of building automation to do this kind of testing and to kind of assure quality into the software. It's hard to evaluate how much it will cost. It's not an easy process. It will take development time away from the software. So a lot of companies see it as an investment, and they don't feel secure about the returns from it. But I think it's one of these things that developers and managers and CTOs and people have to have an intuition that, okay, maybe it will take me a lot of work to automate certain process, but I will never have to spend a lot more than 2 minutes doing this thing again that used to take me 2 or 3 hours to do. And when you're doing processes manually, there's always room for error. There's always room for skipping a checklist, skipping an item, skipping something, and then the quality assurance falls apart, right? So it's expensive to build these kinds of mechanisms, but at the end, I think it's worthwhile, very worthwhile. And as soon as companies and industries start to migrate to this kind of mentality, they realize how good it would have been to follow this methodology from the start, and not and so to bet on automation, to bet on quality assurance right from the get-go, to invest in this kind of mechanisms, because in the long run it will save a lot of time, it will save a lot of problems, it will save a lot of it will even improve the company's the client's view and idea from the company, because you're getting products that are actually good products, and they don't crash at random times, they don't do crazy things, and these can only be achieved in a consistent manner by automation and by quality assurance, and this requires an investment. So one of the biggest challenges is it's convincing the companies that it's a worthwhile investment, and it's going to save time, it's going to save money, and it's going to produce better products, better software, and happier customers.
Thank you, João. We don't have time for much. I just wanted to add here a question from Ernesto. That it's I think it's a very interesting question. Is that in the future there will be no testers? That's the question, or we still have space for them?
Okay. I think this is one of those questions that I have to answer. It depends. It really depends, because I also don't believe that there is a general solution for everything. So, for instance, when you're talking about, for instance, doing a video game, okay, it's not enough to just test the individual components, to put some verification, to do some automatic tests of the game. You actually want to have a person involved, to have a human involved in trying out the features, trying out, and this because having a person also brings a different kind of input. A verification algorithm only says true, not true, it's okay, it's not okay. Whereas a person can tell you, oh, I didn't like this animation, or this button seems a little bit small, or I couldn't find the information in this menu or in this. So I think to answer the question, I think testers are not going to disappear completely, but some of the most boring tests that testers do will disappear, and I think even testers will be happy that we kind of go in this way of eliminating repetitive tests and actually putting this verification, these mechanisms throughout the processes, because it will save time to the testers of doing repetitive tasks and well, almost brain dead, like no challenge whatsoever involved, no feedback. It's not even a subjective feedback that they could give you. It works or it doesn't work. And testers will be and will still be extremely useful when you want more subjective feedback, or when you're analyzing a system that is so complex that you cannot actually program a verification or a validation algorithm. It would not suffice. It wouldn't be good enough to have like, or it would be very hard to build an algorithm, a method for testing a very complex system. And in these cases, I think having persons, humans doing some tests, it's not going to disappear completely. So it's different kinds of things that need testing. So we're arguing that the repetitive, the basic ones are the ones that should be eliminated, and even testers don't like to do them. And it's a point of failure. It's a point where some mistakes can also happen. Some validations cannot, maybe are not done correctly, and automating this kind of tests and reducing the testers is what we're pushing forward.
Thank you so much, Joel. I know it was a very tricky question for you. I wanted to thank everyone that's been participating. Unfortunately, we're going out of time. I'm just going directly to answer the questions that have been raised by Sonia and Ernesto. Sonia, yes, please come do a master thesis with us. We have a lot of students from universities doing their master's degree and their PhDs, and we've been helping them on their research projects. So you're more than welcome to talk to us. And Ernesto, regarding using our framework, I invite you to talk to us to understand a bit more in detail how could our framework and our Genio help your team to improve their productivity and also help them out when it comes to building quality procedures during the development phase. So please feel free to contact us and talk to us more about this. And also, I think it would be interesting if you could check the diagnosis that we have. I've been sharing here the link so you can understand more in detail how could we help you out, we help your team improve their productivity with automation. So again, I would like to thank everyone to participate on this session. Thank you, João, for the amazing set of inputs that you've shared with us. It's been great, very insightful, and I've learned a lot from you today for sure. And I also invite you all to be part of our Model AI group in our meetup, and to stay tuned for the next sessions that we're going to have on the next couple of weeks. Thank you, everyone, so much. Have a great day.